One reason PrecisionTree is so useful in decision analysis is that it forces you, the decision maker, to think hard about your decision problem. You must think logically about the possible alternatives, the possible outcomes, the probabilities, the monetary or non-monetary consequences, and the timing, that is, which events occur in which order. Then you can use PrecisionTree to illustrate all of these elements in a spreadsheet. Even before looking at PrecisionTree's calculations and its recommendations, this modeling process probably gives you a much better understanding of the problem itself, and you then have a better mechanism for discussing it with your colleagues. Decision trees have traditionally been the favorite way to model a decision problem. A decision tree lays everything out clearly and precisely. It is especially good for displaying the timing, because time flows from left to right in a decision tree. However, PrecisionTree provides another tool, the influence diagram, for modeling a decision problem. An influence diagram is a much more abstract and compact way of modeling a problem than a decision tree, but it is very good at providing a high-level view of what influences what. Therefore, even though a decision tree might ultimately be most useful for finding an optimal strategy, an influence diagram can be used initially to communicate the elements of the problem in a visual way. I will illustrate a very simple influence diagram here, just to give you a sense of how it is built, and I will show you how an influence diagram is always equivalent to a corresponding decision tree. I will stop well short, however, of showing how all of the elements of a complex, asymmetric decision tree can be built into an equivalent influence diagram. This can be very tricky, and it isn't clear that it is worth the trouble. If you have a complex decision problem, you might want to start with an influence diagram to simply illustrate what influences what, but you will then probably want to create a decision tree because it is more straightforward. In the simple example illustrated here, a retail company currently has three possible decisions: one of two new ad campaigns or no new ad campaign. The incremental costs over current costs are shown. The payoffs in terms of incremental revenue are also shown. The associated probabilities reflect the fact that more expensive advertising tends to improve sales. To start an influence diagram, click the Influence Diagram /Node button on the PrecisionTree ribbon. Then select a position for the first influence node. This will be a payoff node, and you should position it in a blank area of your worksheet. When you do this, everything else, in this case your data, will be pushed down to make room for the summary statistics associated with the influence diagram. Then you can click OK, and you can provide a name for the new diagram and click OK again. Next, click the Influence Diagram /Node button again. This time, because an influence diagram already exists, PrecisionTree knows that you want to add a node, and it asks you where you want to position the node. After you select a cell, you get the typical PrecisionTree Node Settings dialog box. Fill it out as shown here, so that you now have a decision node called Advertising Decision. Next, click the Outcomes tab. Click Add to add a third decision option, and name the decisions. Next, click the Exit to Value Table button. This gives you a chance to enter information about the decisions. In this case, their immediate costs. Enter these as negative numbers, as shown. 0, minus 100,000, and minus 200,000. And click OK. Now you have two nodes in your influence diagram. The next step is to create a chance node called sales increase. That's a chance node. I want it to have 3 outcomes: low, medium, and high. However, do not click Exit to Value Table yet. Click OK instead. Now you have 3 nodes in your diagram. Next, the nodes must be connected by arcs to indicate what influences what. Clearly, the advertising decision and the sales increase both affect the payoff. So click the Influence Arc button and identify advertising decision as the source node and payoff as the destination node, and click OK. When you click OK, you see this dialog box about the type of influence arc. But because payoff is a special kind of node, you won't have any options, so click OK. Then add another similar arc from sales increase to payoff. Finally, add an arc from advertising decision to sales increase. Now you have options on the type of influence arc, as shown here. But you can accept the default that the influence is of the value type. This simply means that the values of sales increase, actually their probabilities in this example, are influenced by the advertising decision. When you click OK, you see the final diagram. Actually, this is the real goal, at least for most users, of an influence diagram. It shows what influences what, and you could stop here and have a perfectly nice diagram to discuss with colleagues. However, I will perform 2 final steps so that the influence diagram is equivalent to a decision tree. First, I will right-click Sales Increase and select Influence Value Table. This is the same dialog that we've seen before. Here I can enter different values and/or probabilities for the various sales increases for each advertising decision. Here are the decisions, and here's where I can put values and probabilities. They're allowed to be different because there is an influence arrow from the decision node to the chance node. Now I'll fill these in from the data of the problem. Now the probabilities. And click OK. Finally, right-click the payoff label and select Influence Value Table again. Now you can indicate how the elements combine to obtain the final payoffs. The white area actually works like a spreadsheet column. So in the first row, you can type an equal sign, point to low, a plus sign, and point to no campaign. Hit return. This enters the formula equals D4 plus E4 that you see. Cell D4 doesn't refer to the original worksheet. It refers to the mini worksheet in this dialog box. And also, remember that the value for advertising is a negative number. So this formula is actually subtracting the advertising cost. Then you can copy this formula down in the usual way and click OK. That is, I can drag this fill handle. The only change you will see is in the summary section, where I will format the values as currency. These values indicate summary statistics of the optimal decision. To actually see the optimal decision, you need to convert this finished influence diagram to an equivalent decision tree. This is easy. Right-click any of the node labels and select Convert to Decision Tree from the Model drop-down list. You see this decision tree, which identifies Ad Campaign 1 as the best decision with an expected net payoff of $90,000.